So this session, I will talk about something called the Twine, and that is an algorithm made by Lars Rönnbäck, who also is the father of anchor modeling. But before going into the session, my name is Erik Bouvin from Sweden, living in Stockholm. Work as a data vault modeler and data engineer at a consultant company called Top of Minds. And we are the data vault preachers in Sweden, where we both educate our customers and our consultants. And why we can do so is that Hans Hultgren, who is the president of Genies Academy, who do teaching data vault modeling classes all around the world, is also one of the founders of Top of Minds. So we have a global ear out there of what's going on in the ensemble modeling community. And as much as I love my job, I am at my best when I take this jacket on and put my football coach training jacket on. I am a football coach for my son's team and has been that for 5 years, which is amazing to follow kids from 5 years up until 11 as they are right now. But we're not here to talk about my football coach career, but rather how we can go from Data Vault being a modeling approach where we easily can add more data to our existing model in an agile way, right? Where we don't need to re-engineer or reload the existing models. But how does that go in hand with the data marts and the dimensions that is, as far as I know, today is the most popular modeling approach for the BI tools, but also for analysts. So I will go through how we can go from having a high a modeling approach which is very agile to one out here, which is not that super agile. And I will do so with this algorithm called Twine. And my expectations of you who are here, I'm assuming that you are aware of ensemble modeling and possibly Data Vault in particular, but also how these Kimball dimension and Data Marts and the modeling approach for that. And you don't know anything about this algorithm called Twine. I will try to explain that as best as I can. So this session will be split up in two parts. The first will be to see how we can have our facts and our historized dimensions in sync with each other as we are doing changes and add data points to our existing models. And the second part will be about how we can go from ensemble to a historized dimension in the Data Mart layer, bypassing the point in time artifact. And of course, I hope you have some questions or comments as well. So what is the challenge that we have when we go from a Data Vault model to our Data Mart? We'll try to explain this by this first project phase that has been defined by our product owner, and that will be that we will add sales and customer data into our new analytical platform. And we have, and our product owner has split this up in 4 different sprints, because when we sold in our Data Vault, right, to our client, we say that we do this in an agile way. So the first sprint, we are setting up the sales by time. So here on the left, we have our Data Vault model. And if you are a Data Vault 2.0, if you're using that approach, I assume you are having this as a transactional link instead. But of course, as we are smart, we are at this point in time also, we are creating our customer hub and populate it so we have the linkage to the customer. And of course, we populate this customer hub from the sales data. And up in the Data Mart, because this is our end product, the sales fact table, we do create all the columns that we are to be required. But right now, you see here that the D customer key here, we cannot populate it because at this time, we have no idea about which version of the customer that we should link each transaction to. But anyhow, we go on to the second sprint of our first phase and starts adding customer data to our customer ensemble. And here down in the Data Vault model, we simply add a satellite. We don't need to do anything else. But when we go out here to our Data Mart level, of course, we create our first iteration of the customer dimensions. And again, it has history in it since there is a type SCD2. But now we've done this, we also need to reload our fact table in order to key every transaction to the correct version at that customer. And we go to our third sprint and add more customer details. And again, back in the Data Vault model, we simply add stuff. We do not need to do any re-engineering or reloading. But out here in the Data Mart area, we do add our new attributes, which of course, these 3 attributes have history of it as well, meaning that we again need to reload the fact table, even though we haven't changed anything here, just to re-key it so it connects, so it's connected to the correct instance of a customer. And finally, we finalize project phase 1 with adding the final set of attributes of the customer. We populate it in the customer dimension, and of course, reload the fact table once more. And now this is on Friday afternoon, and we are celebrating that the first phase of the project is over. But what we didn't know was that 4 days ago, the source system that populates one set of the customer attributes has been offline for a couple of days. And now we get all the history for the past days, which of course, again, leads to that we need to reload the fact table. I'm assuming that you are handling this in a more nicer way than I just illustrated. But what I did in a previous project, which was roughly 4 years ago, we started with the approach in the consumption layer or in the Data Mart layer that we would separate what we call the ELT or the ETL destination for the fact. Here that we did have all columns here, but here you see the D customer key in gray. And this is where and the reason for it, because we do not populate the key instance of the customer here. But what we do is we ensure that we get the customer ID, hence the identifier of the ensemble of the customer, the customer ensemble in here. And out here, we have an end user view which all our BI tools and data analysts and data scientists and whatnot are using. We prevent them from using this ELT destination, but make sure that they are querying against this view, because this gives us some flexibility to handling the versioning that we are connecting each fact row to its proper instance of, in this case, the customer. So what we initially did in that project was simply to do a range join between the sales fact table and the customer dimension, joining by the ID, and did a range join here in order to propagate this key. And this went very well for a while until we got some complaints about performance. And that is when we needed to find a way that gained the performance without losing the flexibility and the agility with this. And that is when I came across something called the Twine. And the Twine, the definition of a Twine goes like this. A Twine is an efficient set-based algorithm that can be applied when you have a table in which you have recorded a history of changes and some other table with related points in time for which you want to know which historical rows were in effect at those different time points. Again, this has been, is the father of the Twine is Lars Rönnbäck and not me. And it took me a couple of times reading this extremely long sentence to figure out what he meant. And if we take our dimension example here, and if we have the fact table down here, and here we have in the dimension, we have the different version of me, Erik, populated here on a time axis going from left to right. And down here, we have a fact table, me purchasing something on the same time axis. So what a Twine does, that it takes multiple, two or more different timelines, but which are connected, put them in a single timeline, and from there we could easily identify from the fact perspective which version of Erik was valid during this time point. So from the fact reference here, when the time that I did buy something, the version of me was this one. And when I bought something a little later, the version of me was this one, and so forth. So with this, and yeah, and Lars added some simple SQL, and this is actually the Twine. So what it does, it takes the combination of sales and facts. We know the customer ID in both of them, and we have a time point in both of them. And we define these as two different timelines. And on top of it, we add a sliding window function to have the final result. And then what we do outside this window is that we select the fact timeline, so we know and get the output from which customer version in this example was applicable at that point in time. So the end result, which I refer to here as T, as in Twine, sale customer, then results in table, if you materialize it like that, with a date key here, which in this case is populated from the fact date key, which is partitioned, which customer ID and which version of that customer was applicable at these 4 different time points. So with my gained experience, I went back to my setup and went from joining the customer, joining here the sales table to the customer with the range join, which is starting to be a little bit of a problem, and replaced it with the twine instead, so we can have efficient pruning here. But the problem was that, well, I needed to populate the key. The twine itself, what it did was resulting which time version was valid. So I needed to rejoin the customer dimension again to get the customer key out. And I can't remember if how the performance was, but I wasn't happy to be needed to join 2 tables where I had just only 1 earlier. So I went back to the twine again and extended it a little bit. So the difference now is that from the example that Lars Rönnbäck has provided is that I added the customer key from the dimension and from the fact sales I did not know, so I put that as no, and then use the last value functions with ignoring nulls instead, which gives us the result that for each partition and customer, this is the customer key that it needs to be connected to. So again, went back here and replaced it with the twine. And this flew very well, the performance increased. But what we also did try was simply do like this. Do an update statement directly on the ELT destination, which then made us being able to create the views that simply queried all the tables from the ELT destination. And with this approach, the implementation that I did at this time was on a Exasol cluster, which is, well, is a super, really good in-memory cluster. And in this project, we used this customer twine example with doing this update for all our 19 Marts. There were totally 7 billion transactions in the largest one and 65 million rows in the customer dimension. And to do this operation with retwining and updating the fact for, I think the time history that we had was 5 years. To retwine the full history took something like 15-20 minutes on a daily basis, 15 to 20 minutes. Yeah, and the largest fact table that we did have contained a 3 billion transaction with 18.8 million unique customer version. And that took just 7 minutes. And this is something that has been up and running for now, I believe, 3.5 years. It has gotten to a point that nobody knows about it anymore because it's seamlessly just working in the background all the time. And before and after, I did a comparison about using the Twine algorithm and doing a range join with this largest fact table. And with the setup that we had with the Exasol cluster, compared with the Twine and compared it with the range join, you see that using this Twine in this case was almost 100% faster. So, and by using Twine, and there is a way that we always have the facts and our dimensions always in sync with the timelines of your choice. And when we're loading our Marts, there will be no need for doing lookups to dimension, which leads to that we can have minimal ELT pipeline dependencies. So if for some reason the customer dimension fails during load, we can still load everything else and then rekey the customer instances when we have the customer dimension loaded. And also it has a strict pattern and can and have been automated. And there's no need for manual or semi-automated rekeying scripts. So I will pause there and ask if anyone has any questions.
Yep, any questions from anyone?
Okay, that's totally.
All quiet there.
Yeah, no worries. So I'm gonna continue then. So, and the next use case where I have been using the Twine is when we go from one ensemble in the Data Vault model to a historized dimension here. And if we take this example, right, I believe, yeah, so this would be data for myself in the main satellite. And here I have some address information, and in the third satellite, some communication preferences. And of course, that within each satellite, they are its timeline of its own. So extracting data out from these satellites and union these together, that is not super easy. So that is why, or I at least, have been using these point in time models. And what they are used for, right, is for making life easier to populate or extracting data out of the data vault. And the code for this looks something like this, that there are a lot of time ranges and there are some between joins going back and forth. And when you have a couple of satellites, the code looks, or at least for at least me, looks quite complex. So, and we had in the project that I was working in a couple of years ago, we did have these point in times. So I had a revisit and looked on, could we use the Twine to achieve, to replace these range joins by using the Twine instead? So, and this is actually the code required. And we could use the exact same pattern that I showed you earlier when we were using the fact table and the customer dimension to get the customer key out but we only returned the fact timeline. In this case, we want to combine the timeline across all of these satellites. So then the code looks like this. Instead of 2 timelines, we now have 3. And here you see that I define each satellite as its own timeline here, adding their name to as the timeline. And then simply do following sliding window function upon them, which do return the exact same result as this does. But I wanted to see, okay, and after using this Twine pattern instead, I don't remember, but the code efficiency, the performance gained a lot. Sadly, I didn't measure it, but what I wanted to try to see, would it be possible to remove the point in time model directly? How would the code look like then? So what I show now, I hope you can see it, is basically here, the twine that for each customer and each timeline within these 3 satellites, create a unified timeline across these, and then joining back to satellites again and picking up the attributes. So this is a pattern that I have started using in my current project, where we have, for time being at least, skipped the point in time models and added it and using dbt as our transformation tool, and created a macro for our dimension, where we simply can, with some minor configuration, like what is the dimension key going to be called, like what historization level do you want on your dimension, and then simply point out the hub, the satellites, the target name, which will be the dimension name, how will it be sourced? And in the background, the Twine logic will do the magic behind it. And one of the reasons that we required to have this automated with the macro is that many of the data engineers in the project that I'm working in now have slim knowledge about Data Vault. And therefore, it's quite complicated to how to extract satellite information from the Data Vault model to dimension. And so, and I got this question a couple of months ago, who was like, okay, is this a silver bullet for everything? And I said no, because of course it depends on what platform you're using. The Twine logic is memory, it uses memory. That's the trade-off for the performance. So compared with the range joins. So, and of course, cost is another factor. If we would have multiple dimensions that were needed, that were using the same set of satellites, for instance, then the point in time logic would be needed to be running 2 times instead of 1. So for scenarios where the same set of satellites are used across multiple dimensions, of course, for a performance perspective, most likely, and cost perspective, now we're using the cloud platforms, would possibly be cheaper. But just want to end with saying that the Twine is, or has at least been for me, a really, really good tool to use for when working, extracting data from the data vaults up to the consumption layers. So that was the end of part 2. Did I speak too fast? Is there something that you want to ask or want me to explain a little bit more in detail?
Any questions, anyone? You can put things in the chat if necessary. I've got one for you, which is how you implemented or tested the performance of Twine on Snowflake?
I have not. Sadly, I currently do not work in. I'm working on the GCP platform, and earlier it was Exasol, as I said. But please try out. The pattern is very easy to adapt to, and I can share you an example. Can ping an example with dummy data in the chat here. But what I do think, though, however, comparing Snowflake versus the GCP and the BigQuery, where I'm working at the moment, I do think that the Snowflake performed better than BigQuery with the Twine. I guess, I mean, the cost could be something to look at, how much it costs. And if I may, I'm just gonna go back in my presentation a bit. As I said, right, that in the previous project that I was working with is that we performed a update, and one of the biggest table had 3-point-something billion records. I mean, so we did kind of a trade-off, because with this approach, or you would need to have in mind that you always work with 2 timelines when we are loading the sales in this example, and also when we have the customer information, because it could be right that we in the first minute we are populating the sales transaction, and then if we would update it, we would need doing so again when the customer dimension has been updated. And it could also be like in the example I started with, that one of the customer sources has been offline for a couple of days, meaning that the amount of history that you need to do this update performance is not simply isolated based on the sales transaction, like in this example, but you need also to be aware about the amount of history from, in this case, the customer dimension, how many rows, how many days of history was carried with the data that we now loaded from the customer perspective. And so what we actually did was that we did set up this, but we, after some profiling, because we had some latency in the customer data, that when we loaded it, it would be that we were having effective customer dimension members loading that were effect 2 days ago. So it ended up that what we did was updating 2 weeks back in time, and then had a nightly job that was doing a full rekeying. So it wouldn't be too costful. I hope that made sense, by the way. I don't know. So, whoops. Yeah, okay, since I showed it. So, because I had this question about this dimension macro, the requirements, and the requirements in the current version of which I have made is that all satellites are required to circle around the same hub. And if your dimension has a satellite outside the ensemble targeted, you would need a prep or a business satellite or whatever you want to call it, but make sure that that is circling around the hub. being targeted for the dimension.
Okay, got a couple more questions. Did you pick up on those? So I will ask you if you materialize the information Mart with Twine, or do you just generate views on top of the data vault?
I mean, it depends. Of course, it depends. Let's see, where are those? I think here. So, I mean, to start with, my recommendation in general is in the beginning, persist as little as possible, because there will be so many changes you're gonna do, which, so if you would materialize everything as tables, there will be a lot of reloads early in the project. But of course, you would need to have performance as well. So Snowflake, for instance, is quite powerful. So one way could be that you're materializing the whole vault, and you're persisting the in this case the sales, for instance.
Okay. Will's asked if you'd like to share you're able to share your DBT macro at all. Is that possible?
I'm not good at doing coding like C programming or Python or whatnot, but with DBT, the DBT macros are so super silly easy to do. And I'll bet that if you would ask ChatGPT of how can I do a dimension macro with using Twine, probably it could at least give you a start.
Okay, thank you. Any further questions, anyone? No? Okay, I think that's it. Thank you very much, Erik. That's been very helpful. Gives an idea of how to apply these sorts of questions, these sorts of queries, and looks very interesting.
Yeah, sorry, I forgot, because I did have a last slide that would remind me of, where is it? Share, sorry, here, send those links. So I'm gonna pop up the chat. And what I'm gonna post to you now is first the documentation of the Twine in the first link, and then a YouTube link where Lars Rönnbäck describes the Twine, very detailed. If you're interested, please read it, because it's good material.